See, I've done my personal research. Every time I went for an X-ray, I asked the person, "आपकी qualification क्या है?" Then every time I went for a physiotherapy session, I've been very fortunate in visiting all such type of, all such places. I've been very, very fortunate. You see, God gave me the opportunity to be undergoing CT scan, MRI repeatedly. Then I had the opportunity of visiting labs for X-rays, sometimes for myself, sometimes for the seniors in my family, the elder people, sometimes youngsters. So every time I went for any kind of diagnostic test, I used to ask them, what is your qualification? Are you a BSc? So many cases I got an answer, they are BSc, but they never said they are BSc in physics. So I said, why? Do you know some people who they said, yes, we have some colleagues who have done BSc in physics. The problem is the physics community, the teachers and the entire academy of physics is not giving them the information. I asked them, was the criteria, eligibility in botany, zoology, chemistry? No, it's a graduation in science. So that means BSc Physics is also eligible, right? But they have to do this certificate course for X-ray, for any kind of diagnostic tool, CT scan or MRI or PET and so on. PET will be very sophisticated because they will have persons who understand detectors completely. So it is not just radiation safety officer. If a person wants to go into that field, then definitely one will have to do MSc. Okay, they're not asking for PhDs. They will have to do MSc and then they will have to do their certificate courses which allow them to be the diagnostic masters of such kind of devices. Apart from this, which I am going to just now mention to you, although not in great detail. So the eligibility I told you that in some cases they are just asking for pure graduation or class 12. Okay, because they are considering that whatever knowledge is required they will be imparting during training. Now let us see, we have many graduate students who are not interested in pursuing physics as a special career, MSc, PhD and so on, and they want a quick job, and now it is on ourselves a duty to make a list of these jobs, and I am trying to do it personally without anybody's help and so on. If you help me a little, we all can gather all this information in no time. It will not take, one person takes out one thing and just tries to find out. Our students can go into the food industry and into all those industry which involves radiation. They can go for radiation safety officer, they can go for all those technicians who are operating this, and they can go into all those companies who are manufacturing these devices. Whom are they hiring? I found out that also. So I talked to people who were salespersons of these devices. They are pure B.Tech in some field which is not at all connected to this. They are involved in the sales of these devices. They read this information and try to convince the people, please buy our machine. But these machines which are being manufactured by the industry, they can be involved there. Depending upon their expertise or how skilled they are, they can be involved in the making or in the planning or on the designing or in the sales part. So I realized that there are lots of opportunities which are available for BSc Physics students, but we as academic community need to gather that information, only then we can give. If you call anybody for career counseling, they will not be able to tell all this. I have tried that several times. You can also ask, there are several career counselors, you can go there, you can invite them. So we had career counseling sessions in my college, invited by some other colleagues of my department, and I would just like to share with you on a personal level that in the end I was answering all the questions of the students on the chat box of the online session rather than the career counselor, right? So the normal career counselors do not have this information. And let us now look at what all are the industries in which the students. So does the student know that she or he can approach an industry which is dealing with radiation? They don't even know this. Now you have something good in our Delhi University. They have of late Institute of Eminence in Delhi University. Their prime motive is public and private partnership for the job orientation and job location of students. So if you just write to them, they will be more than happy. So I presented this radiation safety paper there, and I spoke to the audience in as how this can lead to jobs. All they have to do is, the university has an MOU with some industries who are either manufacturing these products or distributing these products. If they are foreign countries, they are distributing it in our country. In most cases, you will find that all these machines are not Indian made. We are importing most of the CT scan and all these diagnostic tools. So the salespersons and their sales offices are there, and if a person understands the physics, that person will be able to convince more, you know. They are just reading and convincing, but a person understands physics and convinces. And as far as the doctors are concerned, I'll again share my experience. So my father was in Safdarjung hospital and he was on ventilator, and suddenly there was a problem, the ventilator is not working, the device is not working. So I said, why don't you call the technician? They don't have technicians to deal with such instruments. The doctors only know how to switch it on, off, and just to do it. They don't have any further knowledge of how it works, and so on. I said, but at least try. I mean, he has to have a ventilator. No, he'll come tomorrow morning after there is a call to the particular company, and so on. So as soon as the doctor was out, I went near the device and fidgeted as usual with all the kinds of cables it was having, and it started working. So you see, that part, that the doctors are using these devices, they do not have the knowledge of physics. They are relying on that one person in the hospital who has knowledge. Who should be that person? That person should be of physics, because it's a device made by physics, yeah, and lying on working principle of physics. Why are other people dominating? Because we are not telling our students. So it is my personal mission to, you know, make this industry connect. बोलते तो हम बहुत है ना, पब्लिक प्राइवेट पार्टनरशिप, एकेडमिया इंडस्ट्री कनेक्ट, इसके ऊपर बहुत कॉन्फ्रेंसेस भी करते हैं, बट वी डोंट एक्चुअली कनेक्ट. So this provides an opportunity, but I think that more people are required. I alone may not be able to do everything. So if you like the idea, you can join my hands. Vikar, can I have the mouse, please? So now we go to the next part very quickly before we see dosages. So we have again now time till 1:30. Okay. So first of all, we quickly finish our application part, and then we go to the dosage part to understand how dosage is to be regulated. This is again yes. So I start? No. So the application of radiation, we are on unit number 4. The first part, application about medical science, and this is not medical science. That's enough, or do you want to make it switched off? So we finished applications of medical science, which I did just before tea, and this is also part of unit number 4, which is applications of radiation. It is very nicely and completely written in the book of Lilly. It is very nicely and completely written in the book of Lilly, and here I am giving you a glimpse of it by the slides made by a student. So application of radiation as a technique. How many areas are there which are using radiation, right? There are archaeology, art, crime detection, mining in oil, industrial uses, are tracing, gauging, material modification, sterilization, and food preservation. All these areas are widely using radiation without our knowledge that they are using radiation for such a wide way. So these are the table of content for this entire application. And in archaeology, they are determining the age of fossils and other objects through a process called carbon dating, that we know. But they are also using X-ray fluorescence. We all know what is X-ray fluorescence. The fluorescence produced by a particular material when you bombard it with a certain amount of X-rays. So this X-ray fluorescence is widely used by fossils, and you will be happy or pleased to know that in India right now, many physicists who have worked with accelerators are now working with Archaeological Department of India and certain historians to determine the particular age of a particular artifact of archaeology, right? So and there are research papers. So if you just Google up this archaeology and its implications with X-ray fluorescence, you will find that the Archaeological Department of India is now relying on physicists who have X-ray fluorescence within their laboratories to take sample from them, coins and some parts of statues and so on, to determine exactly how much amount of metal is present, or how much quantity of metal is present, and how many types of metals are present. So I suppose you remember this part of history, that in order to date a particular artifact for a particular age, copper age or some other age, you need to know what is the amount of metal used in that particular artifact, which you find out through archaeological sites. So till now they had been using other methods, but you must know that X-ray fluorescence is the only technique which is the most accurate. How accurate? It goes up to parts per million. Its accuracy is parts per million. As a result, even if you find out a coin or some other artifact, if you can collaborate, if you have interest in history, and some physicists are extremely interested in history, for example, and they are using the labs. For example, this is widely done by my friend in Kolkata University at Saha Institute of Nuclear Physics. He has an X-ray fluorescence lab. He goes to the Historical Museum of Kolkata, takes their samples, irradiates, and then gives exactly how much copper, how much iron and so on, and how much percentage of that. And with that information, those historians are able to assess the age of it. So archaeology is widely used. It is all radiation, right? And then coins which they find out. You see, sometimes the coins are not very clear about which era they belong to or which area they belong to, but everybody, the historians know that if the coin has this much percentage of this material and this much percentage of that material, then they know exactly which era or age or year or century it belongs to, and that can be done with the help of only X-ray fluorescence, no other way, and that's radiation dependence. So if your students are interested in this, you can talk to them about X-ray fluorescence. For that matter, Jawaharlal Nehru University has an independent center, USIC, which is called, it has got an X-ray fluorescence machine. We in Delhi University are also trying to see if we can set up an X-ray fluorescence lab for itself, and it has wide-ranging applications, and you can do a lot of research, personal research for your own publications using X-ray fluorescence, and also research for your students and so on, both PhD level, PG level and UG level. So this is one of the applications. Here in Inter-University Accelerator Center, they also have a section where you are having accelerator mass spectrometry, and that accelerator mass spectrometry section is so accurate. All you require is a pinch of a material, and they can find out what is the carbon dating of it. Okay, more details are there on the website, and there are several people who are doing research on it, and also you can take your students to visit this place and gain more information. So this is one of the applications. So this is one place where they can go to if they are interested. You can also collaborate with lots of historians. They'll be very happy, let me tell you, because in chemistry you cannot go to such accuracies which physics can give, right? For that matter, I would also like to point out, many of you know that environment right now is a very important subject, and everybody is talking about environment and environment related issues, which is the only accurate method to assess how much contamination or carcinogenic or harmful elements are present in soil or in plants or in flowers or in the vegetables and the fruits that we are consuming. Only X-ray fluorescence is the most important technique that you can use. So the biologists, the botanists are learning it, and they are trying to manage it, right? However, but for the physicists it's very simple. All you have to do is collaborate with a botany person who is interested in finding out the effect of radiation on the vegetables, or to find out how much lead, cadmium and so on is present in all the vegetables that we are eating. So I was interested in that. My student sitting here of PhD was also interested. We actually collected samples from an environment specialist here in Delhi University, soils from different areas of Delhi University where vegetables are grown, made samples out of it and bombarded it with X-ray fluorescence machine to find out how much material is present and so on. So this is the most accurate method. Another accurate method is proton induced PIXI, so proton induced X-ray emission. That also is connected to radiation only and gives you an accurate idea of how much contamination is there. And if you really read the reports of NPL and so on this, research papers of NPL in this particular direction, you will decide better not to have vegetables. We are having so much contaminated food in Delhi. right? Especially Yamuna bed, all the vegetables and fruits that are grown there have got a high content of all very, very poisonous elements like lead. And all, who is going to do all this? It's only physicists that they have to do. So this is all connected to radiation, right? All you have to do is collaborate with a botanist in any of the institutes. You'll find many research papers in NPL on this. They also do research, adding to it, they also do research on the landfill, the garbage that we throw. It's all going to that area, the landfill area where the garbage is thrown. They pick up samples from there and do X-ray fluorescence on it, and to prove how much carcinogenic or poisonous elements are there in our garbage that's being thrown together. So the areas are vast and huge. You really have to list down, and you find that a BSc student of physics honors or physical sciences can just never sit idle and not have a job. It's just not possible. There are so many opportunities. But we have to first of all enlighten ourselves, only then we can disseminate. So what I am speaking to is what I have gathered out of my own free will as a hobby. It was not part of any, course or something that I learned it. So another part is radiation. It uncovers technical information about paintings. So you have several questions like, is this painting original or not, right? So radiation helps you find out about originality of paintings. Master works go for auction in billions and billions of dollars and so on. And radiation is one way to find out that was this really the original piece or is it a fake, right? And also restoration. Composition of materials, previous alterations and painting techniques have been revealed in X-rays. So it is industry of art restoration requires a lot of knowledge. I spoke to an art restoring person who was doing art restoration. That person was not a physics, and that fellow was trying to understand how this works and so on, you see. And if a physicist would go, it would be so simple. X-ray fluorescence is just a baby physics and can be understood very clearly. So it is used to protect historic artwork, and radioactive materials were used to make the paint that glowed. So you can also make paintings by using radioactive trace elements introduced, and only physicists can tell how much radioactive material should be put and how much can be used in paintings and so on. More details obviously I cannot cover right now. Forensic science, this is just a sec. Forensic science is very, very important. Some of my students told me, madam, we are not interested in going pure physics, but we like this area very much. There was another student who was very much interested in physics, but could not manage to get admission into MSc physics. Right? So for those students, I explored the area of forensic science, and I said, why don't you try doing masters in forensic science? Right now those students of mine are so well placed. They are right now doing one of them has finished PhD and is already a lecturer in a reputed university in forensic science, and another one is pursuing PhD. So forensic science is another area where all BSc physics students can go very easily. Why? Because forensic science is using a lot of radiation and all other related knowledge of physics honors for their profession, right? So MSc in forensic science and then getting absorbed through forensic science is also one easier method of job that you must know about. The government also advertises jobs on forensic science, and all those students who have done BSc physics and then some masters in forensic science, they can be absorbed there. Here we can see, for crime detection, ion beam accelerator and synchrotrons are used widely in forensic science over their samples. Samples of forensic evidence are placed into the beam, particles or photons interact. Now we know all this very well. Interaction releases particles, X-rays or gamma rays. We know how to use the detectors, and radiation is then picked up by a detector, and you can then analyze very much in detail whether the crime, the object which they are dealing with in crime detection, which element was present and so on. So this is one method which is widely used in foreign countries, but in India to a certain extent also they are using radiation to find out crime detection and so on. So this is another industry, and then you start industrial uses. So you have radio tracers, nuclear analytical techniques and nucleonic gauges can be used in the mining industries. These techniques help to improve the quality and recovery of the mineral from the ore. So more details are available. I am going to share you that also right now. In industry, we are not aware, all the industry which is producing very high-tech things, your car tires, your sophisticated machinery, they are widely using radiation, right? Radio tracers and so on. and this is a very important aspect of their usage. Industrial uses also as tracing and gauging. Radioactive isotopes are used as tracers. Method is used to study industrial processes, flow in dynamics, and leaks in pipelines or machinery. In gauging, they are using gamma and neutron gauges. This is used for non-destructive thickness measurements. So they are so accurate that you can find out the thickness of a particular material which you have manufactured in your industry. So all the sophisticated cars and aeroplanes and so on, you can go to the Discovery Channel and see many such videos where they are using radiation to assess whether the diameter, if they wanted to make 1.2 millimeter, is it 1.2 or not? Who can tell? Nobody can tell better than alpha detector and an alpha source along with it. So you see, the usage is a lot in industry of radiation, and if you are aware of it, then students can also approach industry and say that yes, I am aware of it, I can contribute in it. Sometimes you have students who are boys and they also have some family business which is already running some industry, right? And so if you impart this knowledge to them, it also adds to their value and makes them do a better job in their own local industry, right? So, and then there is material modification. Ionizing radiation used to modify material properties. So most of the material scientists, they irradiate their materials with radiation and then they study all the properties within their lab. Most of the people who are working in IUAC, in material science, they are using this property very much. Secondly, you have to understand that this is so widely. If you are just not clear what kind of research should I start, then this is one very easy method to start, because you have a sample, you irradiate it, you study its property within your laboratory or at DU or at your own college, and then you publish that. Further, these material and the data that you produce is used in what? Used everywhere, even in space missions. So whatever is being sent to space is all irradiated material, and everybody knows how much cross section is prepared, how much cross section results because of ion irradiation. So all that research that we the physicists do over materials and irradiation and then how the property changes is widely used by everyone around the globe. So that's one of the great uses of it. So food preservation, which we spoke about yesterday also, irradiation is used to extend the shelf life of food products. Radiation reduces or eliminates, and we are definitely having bananas, all fruits and most of the vegetables, especially tomatoes, which are all irradiated, stored in food containers which are irradiated by gamma to certain doses, and it also prevents foodborne illnesses. So you see, people who are aware of this particular science know how much dosage to give, how much shelf life is required, and the government uses this information to decide when to send the transportation of a particular product from, say, Punjab to Maharashtra. So how long to store, when to transport, and so on. So there is a lot of possibility of people getting jobs in this. So to conclude, radiation has vast applications in various processes that I spoke about. This was the slide made by the students, and here is information that you can very easily get through either ChatGPT or through Wikipedia or through internet. I've just pasted, I'm not going to read it, please don't worry. Just to show you that these information is not something which you have to hunt for and you don't know where to speak, where to search from and so on. This information I think is from ChatGPT, and it is giving accurate information on radiation. I tested it already. On every syllabus portion, every question, it's doing fine. So you see, it's all written, and that's all you're supposed to teach the students. Energize them, make them think, and then they can write small paragraphs on each and every aspect that is mentioned in the syllabus. So this is one part of radiation and its application. Industry, normal life, art, archaeology, industry of various types, food preservation, paint industry. Paint industry is regularly using radiation. If you are not satisfied with this much information, you can go to the book of Lilly. It has detailed section on everything, giving in great detail how radiation is used for. It's also used for plants in their growth. So they introduce the radioactive material in a tracer amount, which can be detected. Suppose it is introduced in root, and then they keep on monitoring the main stem, the leaves, the flowers, and ultimately the vegetable or fruit, how it is reaching up to there. So the radioactive material is helping them understand transportation of any mineral which is within the root and whether it is reaching the root, the fruit or not. So I think that's a lot of uses. And I learnt about this from a person, from a scientist in AGCR. So on Pusa Road you have this Agricultural Research Institute, and they are not physicists, but they are grappling with, they're trying it. So what if we collaborate with all those people? For you it will be not much work, and you can have a lot of understanding, and definitely your work is contributing back to the society. So if you go through even 1 or 2 research papers of those scientists from Agricultural Research Institute, you will say, how is it that they are using all this? It should be I who should be using all this, right? So I was inspired when I came to know all this, and that's it. So any comments, any feedback on this portion? Yeah, please.
The sample is related to the food sample is related to the radiation. What about the nutrition value and the harmful factor on that sample?
Depends upon how much dosage you are giving, whether first of all it is permissible or not. Whatever is permissible is already allowed. So when we come to know doses, I am not an expert of food preservation. I have been only teaching radiation safety, so I cannot tell you exact how much dosage. I always wondered, why do they allow tiffin boxes to go into the metro station X-ray scanner? Yeah. So I asked somebody, said no, they said within the permissible limit. All that food which is irradiated, its shelf life increases, the germs are killed. So radiation is used for the benefit. It is not very harmful. This is what they say. But what is the exact amount of dosage? I am unable to answer that. You see, you have to do a little bit of research for that to find out how much is being permissible. But definitely all those beautiful shining fruits that you find on your market, the moment you see it, you should understand that they are irradiated. So if you really want to have an unradiated fruit, you have to go for the not good looking fruits. You see, they are not good to look. Yes, they have pigments, they will look very bad in shape, and they will not have a beautiful color, they will not have a tight skin. You can immediately recognize tomatoes which are irradiated from the tomatoes which are not irradiated. The skin gets thickened. So once I had left an apple on a table and forgot about it all about it, and can you believe, after 25 days from outside it was still looking the same, although inside it was totally rotten and black. What was it? It's all irradiated, right? And not to say that it's just our country, you cannot avoid it. 90% of the things that you are getting in your market are irradiated, right, to increase shelf life, because they are produced somewhere else in the country, they have to reach somewhere else, and we are so intelligent, we want to have all the non-seasonal fruits and vegetables in the season where it is not grown. Look at us, no? We are demanding things which are non-seasonal. So the industry is prospering, right?
Once irradiated, the fruits and vegetables, once irradiated,
again you see it,
values goes down, but radiation to
who will find it out?
I'm just asking, radiation itself is non-living. When it affects the living cells, it will,
after some time it dies out.
Yeah, it will denature the cell.
Yes.
So we can say the nutritional value of,
you can say that, nobody knows, more research is going on. Whatever is accepted all over the world, throughout the world, that is being used, because
one thing is contamination. Let us say a fruit is contaminated by lead.
जी जरूर.
I don't know how far is it correct, but this is what I do personally. अगर सब्जी लेने जाओ, जिस लॉट में थोड़े कीड़े दिख रहे हो, so prefer that, because that means that is not affecting that insect, so maybe it is safe for you all. खाया हुआ होता है, basically वो शायद irradiated नहीं होता है, इसमें जो radiated सब्जी होगी उसमें कभी कीड़ा नहीं होगा.
You will not find pests there. The skin will be hard, it will shine from outside, the color will never go bad, okay, and it will have a long shelf life. That is irradiated. All bananas you are getting irradiated. See, you can immediately recognize, if you understand all this, you will also be able to recognize. Not good looking fruits and vegetables are not irradiated. The good looking, beautiful, shining, first and further with those red LEDs and green LEDs shining on them.
Actually, it is all about demand and supply. कि तरबूज में मिठाई चाहिए.
Yes.
It is not possible to मिठाई.
This is it. You should never ask for non-seasonal things. See, that's the first thing. If you demand, you'll have more and more radiated things. And at least you'll say, I am not demanding. Then also don't buy. Just think and eat with seasonal things. You'll have lesser of irradiated food. for that matter. But even the seasonal things need transportation without getting spoiled. And in a country like us, which is mostly agriculture dependent, the government is looking for students who can understand, who will be there. Then there is these food preservative hubs which they want to create all over the country. Irradiate it only to the requirement that it does not create germs and reaches the destination state, and not unnecessarily. So there was another conference in IIT Delhi on this. It was called Tech for Seva, where the minister had come and said that, does a single person think about taking up these challenges in the entire country? No, everybody wants a corporate life, AC and computer work. But nobody understands that even a computer software engineer is ultimately requiring food to eat, which needs to reach that person in a safe way. So the point that we have to take is that if we make people aware, and if we also do a self-research about what all job opportunities exist, we can help our students and create awareness and so on. So like whatever I tell you is all because of my hobby, right? So now we come to the last section. Do I have 15 minutes or 20?
Maybe half an hour.
Okay.
अपना practical session extend करना है ना?
See, we are now nearing to one of the last lectures. So I finished unit number 4 completely. I finished unit 1 yesterday. Unit 2 also, 2 and 3 partly I finished. This particular section, if we finish, after that, we will first talk about how the experiments are to be done, and then you will do it yourself.
Why am I asking? Because if that is the case, we want to extend. We can prepone the schedule by 15 minutes, because for practical session, we have to move after lunch to the lunch.
After lunch, we will move there.
Move.
Yeah, first maybe, so it depends on, I have to show you something.
Okay, yes.
And then you can do it. We have to finish this PPT, and then we have to understand how the experiments will be done, and then demonstration.
So that means 1:15 that will be, and then you can have lunch.
1:15, as you say.
As you say, ma'am. Then 2 o'clock we can start the session.
As long as teachers are attentive, ask them.
ठीक है, let us see.
So when you say stop, I'll stop, right? So as long as you are attentive, can you please come forward? Yes ma'am, आप ही को बोल. If you are attending the FTP. Yeah. So you see, radiation safety management, this part we have not talked about much. We have talked only a bit. This is one portion which saves those students who don't want to do much work, because this is mostly factual knowledge. There is no great inspiration lying here. Okay, in this particular portion, it's mostly facts. Learn those facts, understand them, and reproduce them in the form of short answers. This particular unit of this particular paper is a marks giver to the student, and it is lighter on your work because you don't have to do much work. It is just factual knowledge. What is what? So it's like just information that you pass on. However, it is important because it gives you an idea of the dosage, the absorbed dose, the equivalent dose, and so on. Although till now we have not tried to do numericals over these effective dose, absorbed dose, and so on. However, we should try to do numericals over there. And as I said, Shom series of college physics and modern physics has numericals on the dosage absorbed by radiation, right? So the small formulas that are there in absorbed dose and so on can be used for numericals, but rest, that is, what are the radiation units, what is the dosage, how do you manage the safety of it, and what is derived air concentration, what is annual limit of intake, is pure factual knowledge, and the answers consist of simple gaining the knowledge, learning it, and reproducing it. The good part is that it is not difficult to understand, and therefore not difficult to retain, and hence not difficult to reproduce on the paper. So the students are very happy. Let's say it is that, memorize and produce type of a portion out of all the 4 units, and you can have reasonable marks. But I personally think one should think of numericals even on this portion. And then you have radiation safety management. In the first PPT that I played for you, the movie that I spoke about right in the beginning when we came today morning, there we were talking about biological effects of ionizing radiation. operational limits and some radiation hazards, its evaluation and control, and the radiation protection standards. These words look slightly heavy and in the beginning slightly not so inspiring, but the real content is not so much. So would you like me to go into details or just give you a glimpse and then you can read it later on up to your free will? Huh? Yeah, everybody wants a glimpse. That's true. Is that true? I like it. Yeah, sure. So I've just written the words separately: karma, exposure, absorbed dose, equivalent dose, effective dose, collective equivalent dose, annual limit of intake ALI and derived air concentration. I'll show you two different PPTs, one made by student and the other information taken out from ChatGPT and other books. So you will see that both of them are quite identical. So radiation quantities in units, you know what is activity. So the activity which we speak about in radioactivity is the activity that is what we are talking about here, and we have normal units like what is a Rutherford, what is Becquerel, what is Curie, microcurie, conversion units and so on. Here in this portion, to engage the students, do give numericals on activity like R is equal to R0 exponential minus mu x and NT is equal to N0. So radioactivity law and activity, you give numericals over that and they get an idea about Becquerel, microcurie and so on. My personal experience, as I told you yesterday, they are not able to do even radioactivity numericals easily. So that is really very sad to see. I mean, what is the kind of teaching that is going on in our country, that I as a college teacher have to always repeat NCERT syllabi completely line by line and paragraph by paragraph in order to ensure that they really do understand. So you have to start your first week work should start with radioactivity and test on that, and just don't budge. You need a test, you will take a test. So exposure, it refers to the amount of ionizing radiation that is absorbed, that is just exposure, and the unit of exposure is coulomb per kilogram, not used so frequently but used as Roentgen, right? Absorbed dose is the amount of energy absorbed per unit mass of a material or a tissue. So if you consider your body, then you need to know the volume of your body to know how much absorbed dose you are having. The units of absorbed dose is gray, which represents 1 joule of energy absorbed per kilogram of any material. Another unit commonly used is the rad, which represents 0.01 gray. Right? So simple. The moment you read it, you understand, and the student is also happy. What is equivalent dose? Equivalent dose takes into account the different biological effects of different types of radiation. So equivalent, it is calculating what all types of radiation that you have undergone or any body has undergone. The unit of equivalent dose is the sievert, which is equal to the absorbed dose multiplied by a weighting factor that reflects the biological effectiveness of the radiation. Why is this important? As I told you in that particular table where I was showing you that neutrons are most harmful. I showed you right in the beginning, there was this red oval. Neutrons are more harmful. So you will say, I have undergone radiation. But which kind of radiation? Have you undergone neutron radiation or proton radiation, or which kind of radiation? So this equivalent dose calculates which kind of radiation has gone into that material and which is having more effect on your body, how harmful or how less harmful. Another unit commonly used is rem, which represents 0.01 SV. In the first slide, in the first PPT that we saw, if you remember, I had shown you a slide where this SV was written, which is sievert, one of the units. So this particular portion, you have to tell them about Roentgen, about Curie, about Gray, about sievert, about rad and rem. That's all. It's just a list and they get to know the units completely. What is effective dose? It is a measure of overall harm caused by the radiation to the entire body, taking into account the different sensitivities of different organs or tissues. So some organs in our body are very radiation resistant, so they are not affected very easily, and some are affected a lot. So it depends upon how much you are affected by which particular radiation and which particular tissue of your organ of your body has gone bad, right? So it is calculated by multiplying the equivalent dose received by each organ or tissue by a weighting factor that reflects the radiation sensitivity of that organ or tissue. Liver responds very quickly. So the liver is the first thing that responds to the radiation and is affected badly by it. And then summing over all organs and tissues. So the entire body, but with total focus on which organ and which tissue. The unit of effective dose is again sievert. So here you see radiation quantities and all doses are defined. The concept of effective dose is important in radiation protection because it provides a way to compare the risks associated with different types of radiation. As I said, neutron is most dangerous. Last is collective equivalent dose. Collective equivalent dose or collected dose is the sum of the individual equivalent doses received by a population or a group of people. This is very important because if you have a group of people working in very high radiation area, then you need to calculate the collective equivalent dose, and it's done like this. It is calculated by multiplying the average dose received by each individual by the number of individuals in the population and then sum over, just weighted average, nothing more. So the unit of collective equivalent dose is man-sievert because it is a human being dependent, or person-sievert, right? The concept of collective equivalent dose is important in public health as it allows us to estimate the potential impact of radiation exposure on a population or a group of people. You see, this is very important when there is a nuclear disaster. So some years ago there was this nuclear power plant in Japan, and there was tsunami nearby, and then they said no, there is no damage. How did they assess no damage? They have to do all this and calculate and find out about the normal public which is living around that area or is nearby that area after contamination. Now there are just 2-3 things left. What? Karma, ALI and that. 3 things, and then we are done with it. I can't be faster than this. So it is a measure of the amount of energy deposited in a material as a result of ionizing radiation. Suppose some ionizing radiation has crossed over your body, and then you want to know how much is the energy deposited. You are also you are a animal which has got tissue and your bone and your flesh and all the accessories within your body. So how much amount of energy is deposited in it, right? And that is called as kinetic energy release per unit mass of your body. It is used to estimate the amount of radiation damage that a material or tissue will experience due to exposure to ionizing radiation. Yeah, passing through. So the ionizing radiation is passing through it. You are not standing in front of a source only. Karma is defined as the sum of the initial kinetic energy of all the charged particles produced in a material. The material is U, per unit mass of that material. Karma is typically measured in units of joules per kilogram. It is energy. There are several different types of karma depending upon the type of radiation and the location within the material where the energy is deposited. So it might be that only some part of your body is exposed and the rest is not. For example, collision karma refers to the energy deposited due to collisions between charged particles and atoms in that material, while absorption karma refers to the energy deposited due to absorption of radiation by the material. So as you can see, all these portions are basically factual, right? But you need these quantities also. I found a very good numerical that a person had to repeatedly undergo x-rays for some brain, some fracture in the leg. Calculate how much dosage did he receive. So it was something very nice, and we used some units from here and calculated it. Karma can also be calculated for specific organs and so on. Let's go to annual limit of intake. I'm sure karma is clear to you because it's kinetic energy release. The ALI is the maximum amount of a radioactive material that a person can ingest or inhale. Why are we talking about ingesting? Because most of the diseases which are not being diagnosed by the doctors, they ask you to undergo radioactive tracer ingesting. Also, not only just for tumors, even if you have some kind of problem with your stomach or intestine and they can't find it out, nowadays it's very normal because it's very accurate, so they ask you to ingest it. But the question is, how much can you ingest? With what frequency? How much dosage? Which particular radioactive tracer can you ingest? So that is ingest or inhale. This is all used in medical diagnostic very frequently now. It is calculated as a product of the relevant dose limit and a factor that takes into account that type of radiation, the biological half-life of the material. So when it goes into your body, what is the half-life? It must die out as soon as your diagnostic test is over. So you ingested it, the doctor starts testing you, and by the time the test is over, you should not have that radioactive tracer in your body. So that means the half-life of that radioactive material is very important. So that is calculated, and the assumed retention. So you should not have the radioactive tracer in your body. And let me tell you, 99% of Indian female population is suffering from thyroid, and the best way to find out is by ingesting a radioactive tracer for your thyroid gland malfunctioning. And also Now they are using for gastroenteroscopy and all diseases of intestine. So just ask you, ingest this and we will trace you out, right?
Gadolinium is ingested.
Yes, exactly, and iodine also.
Iodine.
Yes, tracer. Yes. The ALI is expressed in units of activity, becquerel. We know becquerel and curie, so these are simple units, right? Now, that was one part of the PPT prepared by my student. I am now quickly not going to read through this as you are going to have it. You see, all this information is just taken from the internet directly and also through ChatGPT. You'll see. It's so simple. No problem, just say hello ChatGPT, why don't you give me an answer on what is karma, and there he rolls out the answer to you. It's as easy as that. So your work is not increased and your real, and they're giving conversion units and so on. I only did the beautification of putting it on the PPT. Same information which you are getting through books, it's all there, yeah, equivalent dose. So let's say each type of dose, the student should be capable of understanding it and explaining it in say one page, something like 200 words maximum, not more. More than that time neither you have nor they have. So this is just to tell you, you see these small formulae are there which you can use as numericals. And the last part is operational limits of radiation hazards. Here we have in detail what are our exposure limits. So exposure limits, I am reading out just one or two lines. Occupational exposure limits are set for individuals who work with or around the source of radiation in various industries including nuclear power plants, medical facilities, research laboratories and industrial applications. So this International Commission on Radiological Protection, ICRP, if you just type it out in your Google, you will find that this ICRP, an International Atomic Energy Agency, IAEA, is the guiding force all over the world, and they have prescribed in great detail how much exposure can be taken by which radiation, by which person, according to weight, according to gender and according to age, gender and weight. All three quantities they have mentioned clearly, and you just need to know that. And then again these effective dose limits, how much dosage you can take and so on is all clearly defined. Without going into too much details, one can have a fair good knowledge. And last is derived air concentration. It is a term used to assess and regulate the airborne concentration of radioactive materials. You might say, oh, I'll never go near radiation, but you may never know where you are traveling and how much radioactive material concentration is there. This is extremely important for all the mining industries where the workers are engaged in hundreds of numbers to go into a mine. So again through a scientist I came to know the coal mining industry and the diamond industry employs all the radiation detectors all through their mine to find out how much radiation is existing in those mines before they expose their laborers to go into those mines and take out coal and other important material for us. So it has a wide application, and there was another Discovery channel video over it that the person was not able to find out the source and how he used nuclear detectors and radiation detectors to solve the problem. It was by the coal mines of India. So the DAC is typically expressed in units of activity per unit volume of air, so becquerel per cubic centimeter, and is used to establish permissible exposure limits for airborne radioactive materials. This is also important for many areas. So there is a group of researchers in Punjab who regularly just finds out how much radiation is present around their normal physics laboratories, and they have got good research papers over it. Additionally, when we will talk about practicals, I'll tell you our own department can give in data over radiation. If you have a radiation detector, you can also collect data over the background radiation in and around your college and so on to find out how much derived air concentration is there. Okay, so and then there are regulatory agencies. I suppose you've got the idea completely, and I need not really read out all this. And the last one is annual limit of intake. It is a term used in radiation protection to represent the amount of radioactive material that, if taken into the body through inhalation, ingestion or any other route, would result in a committed effective dose equivalent of 5 DEMS, that is 0.05 SV. This is what I mentioned earlier in the beginning. So this is the dose limit, and this is the annual limit of intake. You cannot exceed that. If you do, as I said, you go on a holiday, right? So all these details are further. And one of the nice things that we can ask is, or we can contemplate about, is that the relationship between the DAC and the ALI is given as follows. DAC is equal to ALI in microcurie divided by 2000 hours per working year into 60 minutes per hour into 2 into 10 to the power 4 milliliter per minute, and then you have this formula to find out how DAC and ALI are connected. I've seen this question sometimes in earlier also. So that's it. With that we come to know, we come to the end of the radiation dose, management, how much is the exposure, all kinds of quantities that they want us to know within the syllabus. I'm going to speak about the hands-on session, that is the practical aspect of our syllabus. So I've already discussed unit number 1, 2, 3, 4. I've tried to give you an introduction over all the 4 units. I've tried to impress you with the fact that this is not a difficult paper. I've tried to drive home to you the fact that you will be having enough material to start with, and that it is a paper which has a lot of opportunities both for teachers and students to enhance personal skills and the skills of the students. And with that, I also have given you a promise and my word that I will share with you all PPTs and all material which I have created, or anything that I have, any book and so on regarding the particular syllabus. At the same time, I have also given you my word that I shall be at your service 24/7 for answering within few hours any query related to the paper, right? And also help you in every way, in whichever way I can, for conducting this particular paper in your college, right? This particular paper, radiation safety, was being taught only in Kalindi College and in ARST, and because of some confusion they were not really doing practicals in ARST, because as you might have also had an idea that how will we do these practicals, how will we conduct these practicals and so on, do we have the devices and so on. So this syllabus also was modified once in CBCS itself, and we took care of the fact that we have enough number of practicals which we can conduct, as I mentioned, without purchase of anything, without investing money. However, you must have a computer laboratory, right? And I think you have been already shared on WhatsApp 3 links. One is Magic Plot, the other is SRIM, and the third one is XCOM. Okay, so I start talking about simulation based radiation investigations. So you have, let me start show. So we have minimum 5 experiments to be performed from the following: graphs to be plotted using any graphical plotting software. So those who love Linux, they can use their own types of graphical plotting software. If you are fond of any other graphical plotting software which you can make available through open source to your students, you are most welcome. I just mentioned Magic Plot because I found that very good and very versatile and very user friendly and very easy for the students to understand. Second, now I am listing this is the syllabus that is being typed here. Estimate the energy loss of different projectile/ion in water and carbon using SRIM and TRIM etc. simulation software. Different projectiles to be used by different students. Second experiment, simulation study using the same software of radiation depth. So in the first one we are calculating energy loss DEDX in water and carbon, right? Okay, by different projectiles which are incident upon water and carbon. In the second one we are calculating radiation depth, or by radiation depth you simply mean range, how far it will go, in materials such as carbon, silver, gold and lead using hydrogen as projectile or ion, right? That's the third experiment. Third experiment, comparison of interaction of projectiles with the projectile number 1 to 92, where Zp is the atomic number of the projectile ion in a given medium. What is the given medium? Mylar, carbon and water using simulation software, same SRIM. So you see 3 experiments have to be conducted by the same particular software. The fourth one too, SRIM TRIM based experiments to study. This is a syllabus, you don't have to click a photograph of it, it's there with you in NEP. I'll share the syllabus. Based experiments to study ion matter interaction of heavy projectiles on heavy atoms. The range of investigation will be projectile number, atomic number, ZP is equal to 6 to 92 and ZA, that is the target, will be 16 to 92. And then what are you supposed to do? You are supposed to draw and infer appropriate Bragg curves. Yesterday I had shown you the Bragg curve, right? So you are supposed to plot that. Further, calculation of, this is the 5th experiment, we are supposed to do only 5. 4 can be done by one particular software only. And the 5th one, calculation of absorption or transmission of X-rays or gamma rays through mylar, beryllium, carbon, aluminium and iron, and ZA is equal to 47 to 92, where ZA is the atomic number of atoms to be investigated as targets using XCOM NIST website given, already shared with you on WhatsApp. So you see 5 experiments require just 2 software, SRIM and XCOM, and one magic and one graphical software, that's all, nothing else. Then you have study the background radiation in different places and identify the source material from gamma ray energy spectrum. Gamma ray energies are available in the website given. So where will you get this background radiation data from? The Department of Physics of ours, if you just write to them, they will provide you this data. This data is recorded by them through gamma ray detectors, and what you have to do, you have to load that particular data and then use the gamma ray energies that are available on internet to find out whether there is some gamma ray around you or not, right? Background radiation. The 7th one is, if you have a radiation meter, you can study the background radiation using a radiation meter. I am not aware of any college which is having a radiation meter as yet. Even I don't have a radiation meter. And then from 8 to 13, experiments which are listed here are all concerning GM counter. You can see it is written in bold and underlined. So if you plan, if you get interested to buy a GM counter, you can perform these experiments from 8 to 13. And if you are not interested, you can still have a nice time by doing the first 5 experiments, right? So, and you can inspire the students by saying, let's have an excursion to nuclear physics laboratories of Delhi University and material science laboratories of Delhi University, and you can make an excursion to the department. By writing to them, they will then show you and your students an experiment on GM counter. That has to be done in agreement with the HOD of physics and the nuclear physics laboratory in charge professors and so on. So let us assume we are not going to do that much work. So the first 5 experiments are what we are going to perform today, and we'll see whether we can do a little bit of practice and be happy with it, right? So does that sound inspirational enough to try it? I suppose it should be. Now, what is important for us to understand in all these experiments? Although I am sure you are aware of all this, however, it is my duty to again mention, out of all the elements of the periodic table, when you start doing these experiments, first of all, display the periodic table in front of the students or ask them to look at it on their mobiles. The periodic table of the elements, have all kinds of elements, solid, liquid and gas, right? And you have atomic numbers starting from 1 to 120 and beyond. However, SRIM has the limitation of only dealing with 1 to 92. That is why these programs or these experiments are only saying 1 to 92. You see Z, atomic number is not exceeding 92. Let us first understand what we have to do. This SRIM software is a small window opens, it says what is your ion. Now what can be an ion? Any element can be an ion. You can start with hydrogen and go on till 92, it will take 1 to 92, right? What can be a target? Again 1 to 92. So actually how many combinations can we do? How many combinations can we do? Can I have water please? 92 into 92, so many combinations we can have. So in the first year, what did I do? I did not follow the syllabus that is written here because I wanted them to practice. So I made my own syllabus in my own laboratory, and although they did all that was written here, additionally I had 30 students, 31, 32, 33, this is the normal strength that I have. So I divided, first girl 3 elements, second girl 4, 5, 6, 7, 8, 9, go to 92. And then reverse order, whoever is the last girl gets as a target. So the first girl has 1, 2, 3, Z1. Z1 or projectile? Projectile, Z is equal to 1, 2, 3. Incident upon? Incident upon? And then the second girl, next projectile, 92. Then again next projectile. So can you believe, you will think, they cannot do all this. Can you believe they did it? They all did it. So 3 projectiles per student, incident upon 92 targets. They sat and calculated, and they did the entire experiment. They plotted the graphs, and I had a beautiful display of how energy loss, radiation, projected range works over the entire periodic table, 1 to 92, because I had everything. And in the end, they learned so much of collaboration. So if I have time, I'll share with you. This paper is used for developing their management skills. Whoever says, I want to do management, it becomes the in charge of of this particular work. That person gives the duties to all the students, and anybody who says, I like management or I like to go for a career related to administration, whoever says I want to, thank you, whoever says I want to study UPSC and such like things, so all those students are given this job of getting all the work done by their subordinates, because the class converts itself into a company. And then they realize how good or bad they are at administration, and how good and bad they are at public relations and human resource management. So I call it a BBA and an MBA within physics honors, and within this class I use these practicals to make them work, correlate, because one girl after finishing her work has to pass on the information to the second one and to the third one, and so on, and this chain must complete in collaboration till the 30th or the 31st girl, and you have 92 combinations over 92 combinations. So if the students can do it, then can you not do it? I'm sure you can do it also. So what is the catch here? We have to understand which ion we are using and which target we are using. Choosing an element as a target is very easy. You just click. We'll just show you. You just click it and it is done. It gives an output within 1 minute, exactly 1 minute. Now look at the hours they were giving you. They have given you 2 hours per week. So if you understand the practicals, you can comfortably snatch out enough time during the practicals to cover the theory and to develop all these skills of the students of management, cooperation, collaboration, getting work done, group work, doing assignments, developing the skills of communication, writing the good answers, or understanding physics, and also PPT making or delivering a talk, and so on. So I use this particular skill enhancement paper to enhance all their skills and not just radiation safety. This is my personal journey. However, you can choose whatever you like. So please note down, this is what we are going to do. We are going to use the SRIM software to calculate all this. In the first one, your target will be water and carbon, okay? And you have to calculate the energy of different projectiles. You can start with 1, then 2, then so on. Let's see how much you can do. In the second one, you have projectile ion is defined. Use hydrogen. It's written there, right? And the target is written as carbon, silver, and gold. Experiment number 2. So you will do hydrogen on carbon, take out the output, plot it. Then hydrogen on silver, take out the output. Then hydrogen on gold, and so on. All the 4. So you'll have 4 outputs, and you will plot those 4 outputs. What do you have to plot? You have to write, you have to plot radiation depth. That means projected range. You have to plot projected range. It's there, you have to just sit and pull it and plot it. We'll just show you. The third experiment, you have projectiles from 1 to 92. You can, in order to try, you can take 1 or 2, okay? And then you have defined targets, Mylar, which is a compound, and carbon, which is an element, water, which is a compound again. So the software allows you to choose water, Mylar and so on, and several other combinations also. If you like the software, you can use it for your personal research as I mentioned. And in the fourth one, you can have all combinations. In order to try your hands, you can take one and see whether you can do it. And I'm sure you'll be able to do it. So these are the 4 experiments, and the 5th one is XCOM, which also has to be done with the other website that I've given. Now I'm going to play a video which will give you a complete idea about it. So the 5th experiment which I mentioned here is with a different website, XCOM. NIST website is given, it's there on your WhatsApp, and you are going to run it and you'll be able to do it. So I have 7 more minutes, let's see. Just give me 1 minute to open that particular. Okay, I have it here. Is this visible? No. Oh, I have to. Is it still showing? It's stuck or something?
नेटवर्क नहीं शायद हॉटस्पॉट से चला
Got stuck or something like that. Yeah, sorry. This I've already mentioned. The websites you already have: SRIM, XCOM, and MagicPlot. Okay. Now SRIM, the stopping range of ions in matter. When you run that program, you have its manual within it. It talks about, it's a collection of software of packages, and it is going to, it has a wide range of applications like ion stopping and range, which we are going to use. We are going to use the first aspect. SRIM includes calculations which gives the values of stopping powers, range and straggling, distribution of any ion in any energy. So when you put a projectile ion and target, it will give you a table which I'll just show you. This is ion stopping and range in targets is what we are going to use in our experiments. Further, it can give elaborate calculations over complex targets. It is also capable of calculating ion implantation over materials. It is also capable of calculating sputtering, how it goes on. It gives you a complete simulation of ion sputtering. All this is not required in our syllabus. It also gives you an idea of how an ion transmits itself through a target, and also ion beam therapy. These are the other things which are available through SIM software, which you have downloaded already in your laptops. However, for us, the first one is sufficient. Now when we start SRIM, the moment we press SRIM.execute, this is exactly what the output looks like. And please see, what are you supposed to do? Nothing. Ion, you have to write down either the name or you have to write down the symbol. It automatically is linked. If you write the symbol, it takes the name. If you write the name, it takes the symbol. Rest of the things you don't have to do anything. You have to decide which target you are taking. If you are taking hydrogen in air and so on, target you have to take. If you are taking a compound, you have to find out the compound through the compound dictionary. You must know the percentages. If you want to write an element, then you can choose an element. So you see, compound is separate, element is separate. When we want an element, we use this, and compound we use this. You don't have to enter any density, etc. It does it itself. What you have to do is, after choosing ion and target, you have to decide your range. So the ion energy range here, the unit is extremely important. It is given in kilo electron volt. So now the question which students will ask you is, ma'am, what range, or sir, which range should I take, right? The range is not defined in the experiment that is given in the syllabus. You have to decide the range. So what did I do? I covered everything, starting from the minimum possible to the maximum possible that the simulation can allow. You, to start with, can choose smaller range, but please remember the unit is very important. It's in kilo electron volt. However, it allows you to perform the experiment up till giga electron volts also. right? So you decide the ion energy range, the ion and the target, and also you decide the stopping power units. Several units are possible. You decide to on one unit and stick to it. If you are going to use only kilo electron volt energy, then use a unit which has got kilo electron volt. But if you are going to use million electron volt energy, then use a unit which has got million electron volt. But stick to one unit, don't switch units again and again. So I am sure this is very simple to understand, that the energy and the units should have some consonance, otherwise you will have huge numbers and you will not know what to do with them. Then you have to just press on calculate table, that's all, and it gives the calculation. If it gives the calculation, what does it look like? It gives you an output like this in 1 minute. It gives you an output which says SRIB version, calculation date. It mentions the ion you have used. I had used platinum for this output. It tells you the target you have used. I had used carbon. It gives you the Bragg correction. It gives you stopping units which you have chosen. This stopping units is chosen by me. So I had chosen million electron volt per milligram per centimeter square, right? And I had chosen platinum and I had chosen carbon. These are my choices. Then this is the topmost part of the table. It's a very long table because it will calculate all the energies at equal intervals, whatever range you have given. So if you say 10 kV to 10,000 kV, it will calculate for all and give you a long table in the output file. So ion energy is mentioned here. DEDX, which is the stopping power. Stopping power is of two types, electronic and nuclear, and it mentions the range. Okay, this is the radiation depth. So what do we have to do after plotting? After calculating, we get an output. Copy the output, take it to Excel, paste it, or go directly into any graphical software and plot the graph. Plot the graph of what? Plot the graph of DEDX when we are talking about stopping power. If you are talking about range, then plot the graph of range. That's all. Is it difficult? It's nothing. It's a cakewalk actually for you. But for the students, what is the skill that you are going to teach? You have to excite them about this. I am going to teach you how to deal with simulations for the first time. They haven't dealt with simulations as yet. This is the first hands-on simulation, and you can tell them that all material scientists generally and all accelerator physics people have to first deal with this in the first year of their PhD. And you are getting a flavor within your graduation. Wow, you are so lucky. I was never so lucky. So you start with those sentences and then you calculate them with them this particular output, and when they have got this output, most of the students, at least in my college, are not very well versed with Excel and graphical plotting softwares, because you are basically having second year when you are doing this sec, if not first year. First year you will not have now, unless you float it now coming, you can start with second semester. So in any case, you will not have this paper with experts of Microsoft Office and Excel. So within this particular laboratory, you make them capable of handling any kind of data, right, in Excel and in graphical software. In this particular experiment, you teach them how to plot a graph of any data. And then if you are dealing with those same students in any other laboratory, modern physics or any solid state or any physics laboratory, you can say, well, I taught you that. So now you cannot give me graphs only drawn by hand. First of all, draw by hand and then go and plot it on magic plot. You won't believe, my students readily and happily did both. They first made the graph with their hand in those physics laboratories, and then because they were so good at magic plot and their plotting, they would plot a graph on magic plot also and attach it on their laboratory copies. So it's their skill enhancement that they're capable of dealing with data, and then you further teach them a little bit about Excel, about formula and so on, so that they don't have repeated calculations in physics laboratories and they can immediately find out whether their answer is correct or not. So it's a kind of a lucrative idea to them that their skill is enhanced regarding graphs, Microsoft Office, Excel, etc., formula calculation, and it reduces their workload in physics laboratories. And all this can be done by just these experiments, because you have ample time and doing the experiment actually takes a very small time. Further, you ask them always to make an electronic laboratory file and not a printed or written. Then they will learn how to use Microsoft Word with proper formatting to their benefit by pasting first the output of the program, then the Excel sheet, and then those graphs, and then their inferences. And you can also save paper and say that you are an environmentalist by saying that we will just print one copy, rest of it will be there on the Google Classroom. So there is no need to make copies, there is no need for you to sit and go through pages and correct. And they get enhanced skills because they learn how to make an electronic copy of or a laboratory record of these experiments. So let me show you that quickly. So you see these kind of graphs, they plot it. It's not done by me, these are all done by students, and they can write inferences about electronic energy loss and so on. This is the output, one particular output that they have done. I'll skip this video where a student is explaining SCRIM without video. I'll go to XCOM directly because I have just 5 minutes before your lunch starts. So XCOM, which is the fifth experiment which I talked about, which requires that NIST website. What are we going to calculate here? I'll also give you a movie where the entire procedure of how you're using SRIM to plot the graphs, I'll share it with you on WhatsApp just now. So you can watch it and we'll demonstrate it also immediately after lunch. So calculation of absorption, transmission of X-rays, gamma rays through Myler, I spoke about this and we're going to use XCOM. This is the website. It's a computer program and database are presented which can be used to calculate what all it can calculate. It can calculate photon cross sections for scattering, it can calculate photoelectric absorption, pair production, it can calculate total attenuation coefficient. So just in case you decide to teach nuclear physics later on or modern physics, you can use this software freely available to give them idea about the numbers. And the energy is from 1 kilo electron volt to 100 giga electron volt. If you establish this particular website and go to this, then this is what it looks like. The XCOM website, as you start off, it looks like this, and it simply asks you choose the element, choose the compound, choose the mixture, and then later on it says enter additional energies if you want, and then it just says calculate. That's all, 1 minute's job. I'll also show you how it is done. So when you click, this is the second screen that appears. In this screen, as you can see, you choose the atomic number, then you choose which kind of graph you want, see how many varieties it is offering you. You can do small projects with your students just by this particular software. You can have pair production, photoelectric absorption, incoherent scattering, coherent scattering, total attenuation without coherent scattering, and so on. We just do with the first one and keep our work simple to start with. Okay, and then you want which kind of output you want, you just click this. If you want additional energies, you include that, otherwise you choose the range here. So what all do you have to do? Choose the atom or the element, choose the graph option, choose option of output, and then energy range. That's all. And then you say here, submit information, and within 1 minute it will calculate. After it calculates, it gives you a complete table just to give you a glimpse, and you can plot a graph. Done. Then you can spend the time making them understand what are they observing. That's more important. The students are now also tech savvy. They also know how to quickly do things. You can also show how quickly you can do things, and then you can talk about real physics, which is more important than sitting and writing tables and drawing lines, sometimes verticals and sometimes slanting. Right? So now.
Good afternoon, teachers. Myself Sakshi. Today I am going to discuss about XCOM website. XCOM is a web database. It is used to calculate photon cross-section for photoelectric absorption, scattering, and pair production, as well as total attenuation coefficients for any element, compound, or mixture whose atomic number is less than n, and its energy ranges from 1 kilo electron volt to 100 giga electron volt. Now, first of all, we will search for XCOM website on Google.
You see, she's actually performing everything right in front of you. It will take how much time?
Maybe element, compound, or mixture. We can also add our additional energies by hand. Now we can click on submit information. Now you can add details for your experiment, like atomic number, its energy ranges, and between which things you want our graph. Now I'm selecting 21 standard. You can add its atomic number 21 or its symbol S. You can choose your graph options like total attenuation coefficient with coherent scattering, without coherent scattering, incoherent scattering, photoelectric absorption, pair production, nuclear field, electron field, etc. Now clicking on submit information, then graph and other options is clearly visible, and you can get your desired results. Proper reasons will be given to the graph in the window shown here. Thank you, everyone.
So you exactly saw how much time does it take to perform an experiment. Nothing. But to understand the graph and to understand the inferences of it and to understand the physics of it is what we are experts of, and that is what the students have to understand, that you can develop all these skills. This XCOM gives the graph directly, but SRIM will not. For that they will have to labor, and let me tell you, it takes more time to teach them all these skills of graph management, plotting in Excel, calculating in Excel, dealing with Microsoft Office and so on than you can think. However, the results are amazing, and I'm sure you'll also like it. So, usage of magic plot. Okay, just give me one or 2 minutes and then we go, right? So here I had written about magic plot. It's a technical plotting software and so on, just for your information. Voice is not so clear.
Software, it was under Professor Punita Verma, and this particular software is a software in which we can plot a huge amount of data very easily. We can simply import any data table from anywhere just by click. We can fit it linearly, we can fit it Gaussian, we can fit it as the potential function.
So okay, if the voice is not so clear, so I stop here. These are the books, everything is mentioned here in the syllabus which you can use. Those who are fond of going to depths, the proper book for detectors and radiation is Knoll and Leo, which you must have consulted during your masters in Department of Physics or any other university. These are real standard books which are the, let's say, the main books all over the world which are followed for radiation detection. For thermoluminescence dosimetry, this is McKinley. And this book of medical radiation physics is also very good, where the same things are mentioned. Here basically our syllabus is nicely covered within Lilly and in Ghoshal for nuclear physics part, and in Hyde. Hyde is however of a higher type than Lilly. So you start with Lilly and then go to Hyde, don't go do the other way around, then you will find it more difficult. And apart from that you have a book by Ahmed also, and that's it. So with that I think your patience has already reached the limit, and we come to the end of the session. We have discussed how we are going to conduct the practical. I have to still share just one video with you where a student is explaining, just like this student, she is explaining how we reach from SRIM to magic plot.